the analog signal and the quantized signal are compared, in delta modulation two errors occur. The first error is the slope overload distortion, and the second error is the granular noise. The slope overload distortion occurs when the slope of the analog signal is greater than the slope of the successive approximated signal, whereas the granular noise occurs when the slope of the successive approximated signal is more than the analog signal. To overcome these two errors which occur in the delta modulation, a different modulation technique which is known as adaptive delta modulation is used. The experiment of adaptive delta modulation is as follows. The kit of the adaptive delta modulator modem is as shown. It consists of a generator, a S-clock, a comparator and a DAC, which is as same as the kit of a delta modulator. The only difference between a delta modulation kit and an adaptive delta modulation kit is that in the DM kit we had shorted only A and B, whereas here in adaptive delta modulation we'll short A and B as well as C and D. Also in the adaptive delta modulation, the step size of the quantized signal is not constant, it is varying according to the analog signal. These are the connections which are made on the ADM kit, and now we observe the DAC output on the DSO, and the output is as shown. As we can see, the step size in the DAC output is not constant. These are the various step sizes, and the step sizes are an integer multiple of each other. That is, if this is delta, this is 2 delta, 3 delta and 4 delta. As we can see, here the DAC output as well as the ADM output is shown. The DAC output is compared with the ADM output. The increasing step size of the DAC output corresponds to the +1 bit of the ADM output, whereas the decreasing step size corresponds to the 0 bit, and the step size is varying, that is non-uniform quantization occurs, and the step size are integer multiples of each other. This is the filter which is used for the reconstruction of the analog signal. The output of the DAC is connected to the input of the low pass filter, and the output of the low pass filter is the analog signal whose frequency is same as the input analog signal. The analog signal which is generated at the output of the LPF is as shown. This is the analog signal output which is generated. It has a frequency of 1 kHz, which is same as the input frequency of the analog signal.